So Abel, I wanted to talk a little bit more about 5G, OpenRAN, and how they intersect with private network. So Abel, help me understand how OpenRAN figures into this. I agree with you, the big opportunity for 5G is really this private network for enterprise or industry, but in OpenRAN, is it just the appeal in that the TCO goes down when you take that approach, or is there any concern from the buy side that that integration piece will be overly complex or even just more complex as compared to going with a turnkey solution from a single vendor?
Okay, that's a very key question for private networks, OpenRAN and 5G. So let's see the pieces of the puzzle, right? First thing, why 5G is a key technology for private networks. Basically because, the bandwidth that you have right now, right? We're talking about, 100 megs in sub-6, but using massive MIMO, you can get like gigabits per second, the same as millimeter wave, right? So now the speeds are very fast. Then 5G also brings these new services, right? Like low latency that is very important for Industry 4.0, right? All the things like related to robotics or connected cars, right? What also 5G, a key element for succeeding in private networks is some of the features they have. And one key feature is network slicing. Imagine, there are several countries that are not giving dedicated frequencies to the enterprise. So you can have an MNO, the ones who has the frequency, and that can create a specific slice to this enterprise. Because this is the key part that, I think that it didn't fly private networks in 4G on previous technologies. It was because the data privacy and ownership was not inside the enterprise. It had to go through the MNO, right? So having network slicing, what you're doing is like you can move all the sensitive data, all the sensitive what is called network functions inside the premises of the enterprise. And this is what 5G brings. What does OpenRAN, as you said, is that now you have disaggregation of the RAN, right? We also have like a standardization of the interfaces that interconnect all these devices, right? The CU, the TU, the RU, the 5G core. So at the end, what you can do is like, first of all, reduce the TCO, right? Because now, before if you go to traditional vendors, you have to buy, their hardware, their software. But now you only have to buy the radio, right? Normally the radio is going to have just, the RF elements like the amplifier, the filters, and then you have like just a low level of software, the layer one, a low. But then the rest of the software runs on your premises and it can run in commercial on the shelf. That means that you can run in any server. You don't have to have any proprietary hardware. So this reduces a lot of the cost. But also the important thing of OpenRAN is what they want to create is like an open infrastructure to bring innovation on top of that. And in private networks, you can see a lot of innovation. They have a lot of applications that are not related with the standard web browsing, chatting and so on. They have their own applications to communicate, for example, machines. And these applications now, they can fit inside, for example, the OpenRAN infrastructure. There are open APIs that can interconnect with what is called, for example, the RAN intelligent controller to collect data from there. For example, imagine the quality of service or the speed of a machine at that specific moment. And then these new applications, software applications, third-party applications can, interact with the radio on a real-time basis. And this is, you can think of creating like Android or iOS systems where you can get some application, right, that gets into the radio, into the OpenRAN, and collects data and interact with the radio on a real-time basis. And of course, this is something that is really, really interesting. And this is the good thing that brings OpenRAN, because one of the principles of OpenRAN is to open up the APIs.
You said something there that I'd like to circle back to that speaks to this security question. As it comes to OpenRAN, obviously different vendors have articulated different perspectives on security as it relates to a disaggregated network. So maybe you can share your perspective on whether when we disaggregate a network, opening up the RAN and other domains, how does the security logic change? And then in the context of these private networks, What does it mean for data sovereignty when you've disaggregated the network, both in terms of hardware, software decoupling, but also physically distributing it with RU, DU, CU?
Okay. First of all, privacy. With 5G, I mean, you have, I mean, more data ownership because two things. First, all this spectrum that you can buy, so that means that you can build your own network on your own premises. I mean, if you look, the value of in certain countries, for example, if you go to the UK, Ofcom, 10 megahertz cost is very cheap. I mean, you can create your own network. You get this license in less than 2 weeks, right? And you can create your own network with your own frequency, with your own, core radio, in a matter of 3 weeks or a month. So their privacy is very secure because everything is in the house, right? The second, second element is from 5G is this network slicing. Network slicing means that, you have maybe the signaling part is controlled by, maybe a system integrator or maybe an MNO, right? This is not, the signaling part is not such a key element for enterprises. What they want to protect is the data, right? You don't care if you do an attachment or you do a better location, right? This is what it runs on this MNO. But on the enterprise, what you have to have is where the data comes from, all the applications. And this can be a slice that, all these virtual functions run inside your premises. So I believe that, 5G brings much more ownership of data than previous technologies. Then on the second part of the question, security. Well, first of all, when you look at 5G is secure from 3GPP, right? 3GPP is the standard that defines all the features from 5G. So one of the things they do is like to encrypt the end-to-end of the call, right? From the radio interface to the core, to the 5G core, right? So you have already security on the 5G. Of course, now you have different boxes. You have servers, you have radios, and then you have interfaces. What OpenRAN does, OpenRAN is formed by 9 working groups looking at different parts of the architecture. So some looks at the RAN intelligent controllers, other ones look at the different interfaces, the front hole, the mid hole. Each of these groups, they look at the security on that part, for example, on the management side. And if you look, I don't know, I think I lost track of how many companies formed OpenRAN, but I think it's around 70 something. You have 70 companies, top companies talking about, tier 1 MNOs. We have vendors from the RAN, from the virtual infrastructure, from hardware, from chipsets, looking at all the parts of the security. So at the end, you have many eyes looking this open code, right? So we can, easily look at threats. So I believe that OpenRAN, the more we work and the more people are involved in OpenRAN, the more secure it's going to be.
So big picture, Abel, when we think about multiple vendors working together to deliver an end-to-end private 5G network, what do you think are some of the best practices, both on the technology side and organizationally among those vendors that'll really help us drive adoption into this big market?
Yeah, this is also a big subject that we face a lot with OpenRAN. Well, integration and interoperability is something that exists, from any technology, right? If we move to 4G, for example, at Airspan, we have to work with other RAN vendors, right? Because you are coexisting with maybe with an incumbent vendor, and you have to, do handovers with them, moving multi-calls. So at the end, you test these interfaces, for example, the X interface, also with different cores, IMS devices. So interoperability test is something that we are used to. What happens with 5G now is that the RAN is the paradigm shift. Right? Now we have this disaggregating virtual RAN infrastructure. So that means that, for example, we can call it, we have the software and the radio, right? We could bring the software, we can bring the radio, and of course, it's going to work because it's Airspan and we do the testing with ourselves. But imagine that we have the software, we put some radios, and then in the future, the private network or the operator, they like, some radio because it has more power or more antennas or less power or whatever thing. So, and they want to integrate this radio. Of course, it has to be some integration on that part. But again, as long as everything is focusing on OpenRAN, so we are following the same guidelines and technical specs, it should be an achievable task, right? for example, a couple of days ago, we were doing an end-to-end standalone call with a 5G core standalone, right? So it took us 1 week to achieve this milestone with our sub-6 radio and this 5G core. We will try to publish this soon. But for example, I think that different levels of integration. The first one, of course, is vendors. So Airspan, we have a lot of partners like this 5G core, or for example, OSS, or devices, of course, and now radio vendors as well. I mean, we have opportunities where we have mixing vendors. I mean, we at Airspan, I think we are the when you look at the OpenRAN infrastructure, the only one who brings the end-to-end. So we do the radio, right? So we do the radio, but we also do the software, the CU, the DU. We have, I mean, at the end, when you look at the software, the radios always had software. The thing we're doing is like we're moving the software that it was proprietary running on the hardware, and we're moving now to a commercial off-the-shelf server, but still is the software that runs the radio in the virtual infrastructure. So what we do now is like we see opportunities that they request our software or our radios from other RAN vendors that maybe they don't have a part of it, like for example the radio. So we have to do IoT with them, and we can do that internally between us. But I think there are other two levels. MNOs, of course, like Rakuten. Rakuten is a clear example of multi-vendor. It's the first OpenRAN vendor that we see commercially launched. Then the MNO is the one who is responsible to push us in order to integrate the full pieces of the puzzle, right? We can see also what I see from MNOs, they're going to have like a catalog of software and radios. And then I think the third level, when we look at private networks, there is a new entity here that is going to have a key value, that are system integrators. That's why it's so important for us to really partner with, important system integrators they have like, the experience from the field from many customers. Like, for example, they can be petrochemical, they can be like car companies, they can be agriculture. So these are the guys who understands the needs of this end customer for the private network. So when we ally with these system integrators, we get the feedback of what is the use cases they need to do, right? So we can provide our equipment, right? They have like, again, maybe they have their favorite 5G core, the favorite radios like us, and for example, this German system integrator, where they have our CU, DU, RU, millimeter wave and sub-6, right? And they have their own CPs devices. But one benefit that, for example, the RAN vendor should bring is the capability to tailor to the final use case of the customer. That's why the system integrator is key, because they understand how they breathe these end customers. And this is the story with Gogo. When you look Gogo, it's not just a big private network with the full disaggregated OpenRAN architecture. We had to tweak our software in order to cope with the Doppler effect. Planes, they go 800 kilometers per hour, but 3GPP specifies 500 as the maximum kilometers per hour. So we have to change something in the software in order to cope with this Doppler effect. For example, the cell range that we have at Gogo networks is much bigger because the altitude of the planes. So again, we have to tweak this software. So I think this is the expertise that RAN vendors has to bring, like we do, in order to win these projects. When you answer the questions to fit these needs from the end customer coming from the system integrator, I think that is key for that. And system integrators have this value to understand the end customer and the capability to put together the pieces of the network. So they're going to be very valuable in 5G.